Okay, thank you very much. Thank you for this opportunity to talk today. So I'm going to discuss the monitoring program, the SCTS governance program. I'm not going to focus on the political side of it. I'll leave that for the SCTS Executive Committee. I'm going to mainly talk about the methodological side and how the data went from getting inputted to ending up on the SCTS website. I'd just like to thank, again, Heart Research UK, because they do fund my salary for this. Password. How do I work it?
I think you're probably on this one. I think you're on this one, yeah.
Okay, brilliant. Okay, thank you. Okay, so the SCTS has been publishing mortality data for a long time. The background is very well known. Mr. Roxburgh and Professor Bridgewater have both discussed it here today with the Freedom of Information request by The Guardian and also the well-known BMJ paper that published the name mortality data. So just to understand how the data comes, how the data flow works, the data is inputted by the cardiac surgeons into their local databases at the hospital. It then goes to the database managers who have the very difficult task of getting all that data in order and getting it all sorted. And then it eventually gets uploaded by your database manager to the National Institute of Cardiovascular Outcomes Research, which is an institute as part of UCL in London. That data is then forwarded on to me, where it is first of all cleaned, and I work with Professor Bridgewater and Stuart Grant, trainee surgeon, and that took a long time to clean that, and we now have reproducible cleaning programs that can run it very fast in about an hour. The data is then analysed, and some data is sent back to the hospitals where a validation exercise takes place. After that validation exercise, the data is sent back to me, where I may tweak the code or I may tweak the analyses to reflect the comments I got. And the final analysis is then sent to the SCTS Executive Committee, where they make their decisions based on those results and the relevant notifications, and it ends up getting published on the internet, in this case, the SCTS website. So just to discuss the data pre-processing that occurred for the latest round of governance analyses. So as I've discussed, the data's cleaned. There are types of errors that you would have found would have been transcriptional, numerical. You would have had temporal issues. For instance, dead patients ended up coming into surgery. You would have had clinical errors. For instance, an isolated CABG would have miraculously had a valve procedure done somehow. And there's also an issue of duplicate procedures. Some surgeons get confused about who should enter the records, etc. The data that we published was for the 3 financial years, running from 2008 to 2011. We excluded a number of procedures based on sort of clinical decisions made by the SCTS, so transplants, trauma, primary VADs. We exclude minors. So even someone who's 17 and a half years old, they would still be excluded. It has to be an adult in sort of the eyes of the law. We exclude private hospitals. That's an entirely separate analysis we run. And as has already been mentioned, we exclude emergency and salvage procedures, as we've shown that they are not well adjusted for with standard risk adjustment models. So it's very important that we have to risk adjust. What we do know is that the logistic Euroscore, as it currently stands, is not very well calibrated. As you can see on the calibration curve on the right-hand side, it substantially overpredicts risk. So if we were to use this for the governance analysis, we would never find any hospitals that were outliers. We would just find that everyone is performing well above standards, which is clearly misrepresenting what's happening. So there are a number of options we have. We could build a new model. The issue then is that there's going to be missing data for variables that we haven't informed the hospitals that they need to collect. Do we do procedure-specific models like the STS? These are all questions that we would need more time to address. We could refit the existing model, the Euroscore, but then we have looked at that, and it doesn't particularly well fit our data for this period, these 3 years, so we didn't go down that route. The option that we did take is to recalibrate the model, which is slightly different from refitting the model, And I won't go into sort of the statistical nuances of that. But as you can see by the calibration plot on the right-hand side, it was a very good fit. So we were comfortable with our risk adjustment model that it was fair. So we got to define divergence. As you would have probably seen on the SCTS website, we use funnel plots, and we use confidence intervals to classify the outliers for this round of analyses. There are a couple of technical issues that are quite important that are listed here. The first one is for consultant-level analyses, when we're trying to compare surgeons, we have an additional level of classification, this sort of red outlier, if you will. And the idea is that we have a one-sided confidence interval that's corrected for multiple comparisons. So normally when you look at a funnel plot, you're looking at a single point on that graph, you're only looking at a single hypothesis. If you want to compare all the surgeons simultaneously, then normally you will find that some surgeons will be sort of outliers, if you will, just due to chance alone. So we correct for that fact by putting this additional confidence limit on. Because we also compare all cardiac surgery, we don't look at it in different groups, we're not really comparing like with like necessarily, if someone's a mitral specialist compared to someone who's an aortic specialist. So what we actually found is there was more variability in the system than our binomial model would have expected. So we had to adjust our model correctly for this extra variance by inflating it with what's known as an over-dispersion factor. So this plot here shows where the surgeons would lie according to our classification scale. We're really only interested in the surgeons who have a higher mortality in hospital mortality than the national average, which was 2.74% for this period. We had the guys in green, but we're very comfortable with them. They're where they would be expected. Then these yellow outliers, which fall just above the 95% confidence interval. These amber outliers just above the 99%, and then these red outliers which fall above that one-sided 95% confidence interval, which is corrected for multiple comparisons. So that's the limits. So here are the results. For the hospitals, we don't have this one-sided multiple comparisons correction. We found that there were 3 hospitals that were defined as outliers above the 99% confidence interval. There were none below. For the consultants, there were 3 surgeons who were found to be above the one-sided 95% confidence interval corrected for multiple comparisons. I'll point out that all the confidence limits here are corrected for over-dispersion, or rather adjusted for over-dispersion. I can't remember off the top of my head how many amber and yellow outliers there were, but this data is reported to the SCTS, and it then goes onto the website where if you were to click your surgeon, you can find out who these people were. So in conclusion, what I would say is that identifying healthcare providers as outliers is methodologically very challenging. It's also politically very challenging, as you would have heard before. It was necessary, as I'm a statistician, I'm not a cardiac surgeon, that I had to work with clinicians to understand the subtleties of this data so that I could correctly work with it. What I would like to stress just finally is what you've just seen as those outliers, say the surgeons, those 3 surgeons. It does not mean that they have poor practice. An outlier can be for a number of different reasons. For example, there may be something very special about their case mix, or it may just be that their data was poorly inputted and therefore we couldn't properly adjust for those surgeons. And in the future, we will be looking to do more sophisticated statistical modeling with this. We'll be looking at random effects modeling, etc. Okay, thank you very much.